question number 10. So question number 10 wants you to simplify the radical expression, all right, that's given, okay? So first things first, guys, you need to memorize these perfect squares. You need to memorize it like it's the back of your hand, all right? So again, you should know that your perfect squared, which is given to you by multiplying these numbers by themselves, okay? So 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 36, 7 times 7 49, 8 times 8 64, 9 times 9 81, 10 times 10 100, 11 times 11 121, 12 times 12 144. Alright, so again guys, these are all of your perfect squares. Alright, so when you're doing this, guys, you need to memorize this. So if I was supposed to ask you what is 6 times 6, you should know it's 36. 11 times 11, 121. 1 times 1, 1. 3 times 3, 9. That should be automatic for you. All right? So we are going to try to solve and simplify this radical expression. Okay? So the first thing you're going to do whenever you're trying to simplify it, guys, all right, is that you're going to ask yourself, can I multiply or divide them? All right? Because both of these numbers are both underneath a square root, all right, we can assume that we can multiply them. I know that I'm multiplying because whenever you don't see a sign in between them, you always assume you're multiplying them. So again, whenever you don't see a sign in between both those radicals or both those square roots, you assume you're multiplying. All right? So when I multiply square root of 20 by square root of 24, all right, I will get square root of 480. All right? And again, I can multiply them because both of them are underneath a square root. Okay? So now I need to simplify this, okay? So when I'm simplifying this, guys, I'm going to show you guys a method called prime factorization, all right? So there's other methods you guys can use, but prime factorization is the fastest way of doing this without a calculator, all right? So when you're doing prime factorization, you're going to first list out the first 5 prime numbers. So those numbers are 2, 3, 5, 7, and 11, all right? So a prime number is a number that's divisible by only itself and 1, all right? 1 is not a prime number because 1 is itself, all right? So again, 1 cannot be divided by itself and 1 because 1 is itself, okay? And the first 5 prime numbers are not all odd numbers because if you realize 9 is not there because 9 is also divisible by 3. So 9 is divisible by 1, 3, and 9. So because 9 is divisible by 3, it's not a prime number. So the next prime number in this set would be not 12 but 13. Then not 14, not 15, not 16, but the next one after that would be 17. But you only need to focus on the first 5, okay? So what I'm going to do, guys, is that I'm going to try to divide my 448 by my first 5 prime numbers. So do you think I can divide 480 by 11? No. By 7? No. By 5? Yes. All right? Because, again, it has a 0, so I can assume it can be divisible by 5. So if I divide 448 by 5, I would get, I believe, 92, I believe. No, so actually 96, all right? So again, 480 divided by 5, yep, would be 96, okay? Now I will try to divide the 96. So again, I divided it by 5 and my remainder was 96. I put it on the right side. Okay? So now, can I divide 96 by 11? Probably not. 7? Probably not. 5? Probably not. 3? Yes. Alright? So I can divide it by 3. 96 divided by 3 gives me 32. Okay? Now I'm going to try to divide the 32. Okay? So can I divide 32 by 11? No. 7? No. 5? No. 3? No. 2? Yes. Alright? So I can divide it by 2. 32 divided by 2 is 16. Okay? Can I divide 16 by 11? No. 7? No. 5? No. 3? No. 2? Yes. Okay? 16 divided by 2 is 8. Alright? Can I divide 8 by 7? No. 5? No. 3? No. 2? Yes. And I get 4. And I can divide 4 by not 3, but by 2. Okay? And I have a remainder of 2. Okay? And I cannot divide 2 any further. That's as far as I can go. Okay? So now I'm going to circle all my pairs. Alright? So I have one pair of 2. So that means I have 1, 2 on the outside. But I have another pair of 2s. Alright? So that means I have another 2 on the outside that's being multiplied by my other pair of 2s. Okay? So things that I have that are not a pair, I'm going to put a box around it. So I don't have a pair of 5s. Do I have a pair of 3s? No. So I don't have a pair of 3s. And I have a singular 2 down here that doesn't have a pair. So I put a box around my pairs. Alright? So whatever I put a box around goes underneath my radical, and they're all being multiplied by each other. Okay? So now let's calculate. 2 times 2 is 4. Okay? And then when I calculate underneath my radical, underneath my square root, 5 times 3 is 15. 15 times 2 is 30. So my answer for what's square root of 20 or radical 20 multiplied by radical 24 would be 4 radical 30 or 4 square root 30. Alright? So again, guys, this can be tricky, guys. So make sure you follow all that I'm doing here. So let's try to do the next one. So the next one here, I see a fraction, so I can assume that I'm dividing. Alright? However, this has a square root, but does this 10 have a square root? No. So because this has a square root and this does not, I cannot divide the numbers. Alright? If I saw something like this where both of them have a square root, I can. But because this 10 does not have a square root, I cannot divide them. Alright? So I'm going to simplify the square root first, then I'm going to try to divide them. Alright? So let's simplify the numerator, the square root of 24 first. So let's simplify that first, okay, before I can do anything with this 10 at the bottom. Alright? So let's try to prime factorize this 24 using my first 5 prime numbers, which are 2, 3, 5, 7, and 11. Okay? So, can I divide 24 by 11? No. 7? No. 5? No. 3? Yes. So I can divide 24 by 3. Okay? 24 divided by 3 gives me 8. Okay? Now, can I divide 8 by 7? No. 5? No. 3? No. 2? Yes. And 8 divided by 2 leaves me with 4. Okay? Can I divide 4 by 3? No. 2? Yes. And 4 divided by 2 leaves me with 2. Now I'm going to circle pairs. Alright? So I have one pair of 2s. So that means I have 1 2 on the outside. Alright? I have no pairs of 3s. And I have no pair that goes with this 2. So that means I have a 3 and a 2 that's underneath my square root. So it's underneath my radical. And they're being multiplied by each other. Alright? So the 2 that's on the outside of that radical, that's in front, you're going to bring down because you're not multiplying this 2 by anything. But this 3 and 2 are being multiplied by each other and you get 6. Alright? So square root 24 or radical 24 can be replaced with 2 radical 6. So let's replace that, okay? But can I still divide 2 by 10? No, alright? But I can simplify them, because both 2 and 10 are both divisible by 2, okay? So 2 divided by 2 leaves me with 1, and I rewrite the square root of 6. 10 divided by 2 leaves me with 5. And this would be the answer for what is square root of 24 divided by 10. Alright? So let's try the last one, guys. Alright? So here I see a square root of 40. That's over square root of 2. So this is a fraction, so I assume I'm dividing. Because both of them have a square root, can I divide them? Yes, I can. Alright? So the square root of 40 divided by the square root of 2, 40 divided by 2 will give me square root of 20. Okay? So let's try to prime factorize this, guys. Okay? So the first 5 prime numbers are 2, 3, 5, 7, and 11. Alright? So can I divide 20 by 11? No. 7? No. 5? Yes. Alright? So I can divide 20 by 5. Okay? 20 divided by 5 leaves me with 4. Can I divide 4 by 3? No. 2? Yes. And why did I start at 3? Because it was the largest number that was smaller than 4. Okay? And 4 divided by 2 is 2, and I cannot simplify anymore. Okay? So my pairs, I'm going to circle. Okay? And my single person, I'm going to put a box around. So that means I'm going to have a 2 on the outside because I had a pair of 2's. And I have a 5 underneath my square root because I had only one singular 5. Alright? So, again, I could divide them because both of them had square root. I got square root of 20, which simplified using prime factorization to be 2 square root 5 or 2 rad 5. Alright? So again, guys, just like that. Okay? So there's other methods you guys can use. Okay? And I've done videos on other methods that you guys can use.